Good morning everyone. My name is Muskan Kumari and my roll number is 205008. Today I am going to give presentation on the topic theory of equilibrium, types of equilibrium and applications of theory of equilibrium on strengths, system of forces and virtual work. So let's start. Firstly, we have to understand what equilibrium is. In classical mechanics, a particle is in mechanical equilibrium if the net force on that particle is zero. By extension, a physical system made up of many parts is in mechanical equilibrium if the net force on each of its individual part is zero. In rotational mechanical equilibrium, the angular momentum of the object is conserved and net torque is zero, as you can see in the figure. Now let's take an example. An object resting on a surface, as you can see in the figure, the normal force N is equal, opposite and collinear to the gravitational force mg, so that the net force and moment is zero. Consequently, the object is in state of static mechanical equilibrium. Now coming on to the types of equilibrium, which are stable and unstable equilibrium. When a body moves on a smooth curve, as shown in the figure below, it will rest at points A, B and C, which are the positions of minima, maxima of the curve. If the body is slightly displaced from the positions of rest, that is at A or C, then it will try to come back to its original position of rest. Here, the equilibrium of body is stable at A or C. Whereas it is displaced from the position at B, then it will try to go further away from the original position. Hence, the equilibrium of body is unstable at C. Now we will discuss the case of sphere whose center of gravity is not at the geometric center of the sphere. So now the case 1 is, if center of gravity lies on the vertical line through the point of contact and it is below the geometric center of the sphere as shown in figure, and the sphere is slightly displaced, then it tends to come back to its original position of rest. This position is called position of stable equilibrium. If the center of gravity lies on the vertical line through the point of contact, and in this case it is above the geometric center of the sphere as shown in the figure, and the sphere is slightly displaced, then it tends to go back away from its original position of rest. In this case, this is the position of unstable equilibrium. Now the case 3 is, if the center of gravity lies on the vertical line through the point of contact and coincides with the geometric center of the sphere and is slightly displaced, then it will remain in equilibrium. In this case, the equilibrium is neutral. Now let's talk about applications of theory of equilibrium. Firstly, on system of forces. So when an architect or engineer design buildings, they have to make certain that all forces, both rotational or translational, are balanced. When we build a structure like a bridge or house, we try to balance all the forces on each part of the building. We have to make sure that all the translational forces sum to zero. So some part of the building does not move from side or up and down. We have to make use that off center forces don't cause some part of the building to twist or rotate around another point. So these are the applications of theory of equilibrium on system of forces. Now let's understand what poinsot central axis is. There is a figure. Now a line through a rigid body which is parallel to the vector sum f of a system of forces acting on the body, and which is located so that the system of forces is equivalent to the forces f applied anywhere along the line, plus a couple whose torque is equal to the component of the total torque T exerted by the system in the direction of f. Now coming on to the applications of theory of equilibrium on strings. So you use the strings on your hand bag to lift it and carry it around. Depending upon the weight inside the bag, The amount of tension in the string also varies, and eventually, when the load exceeds the load carrying capacity of the string, it breaks. To make it more interesting, consider that two strings on a handbag are of different lengths and the bag is quite heavy. So you take the help of a friend to pick it up. Each one of you are holding different strings. To avoid the bag from touching the ground, you and your friend would be at different distance from the bag, okay? Taking your hand level at the reference to the angle made by the strings on that reference would be different. Which string according to you would have a higher amount of tension in it? The string which makes higher angle with the reference or the person that is closer to that string would have more tension in it. This simple concept of equilibrium of strings can be expanded to generate a complicated system as well. Now you can also observe this application in cable machine exercise at the gym. Now coming on to the application of theory of equilibrium on virtual work, which is our last topic. In mechanics, virtual work arises in the application of principle of least action to the study of forces and movement of mechanical system. An important benefit of the principle of virtual work is that only forces that do work as the system moves through a virtual displacement are needed to determine the mechanics of the system. So here we have come to the end of the presentation. Thank you.